So in this problem we have a square-based pyramid, all the side lengths of 10. The other faces of the pyramid are equilateral triangles of side lengths 10. So all these sides are equal to 10. We've got to calculate the volume of the pyramid, correct three significant figures. So the formula for the volume of a square-based pyramid is 1/3 base squared times height. It's like the formula for the volume of a cone, except the base is a square, so you have b squared instead of pi r squared. So slightly simpler in some ways. So I'll just take that out. So we have the base, it's the height that's the problem. So we'll draw in the height and we'll look at how we can find the height. The height comes down to the centre of the square. And the height forms a small side in this right angle triangle that I've drawn in. So we'll draw this right angle triangle out on the side here. And that right angle triangle has height, and we know the width is half of 10, it's 5, but we don't know the hypotenuse at the moment. But the hypotenuse is part of one of the faces of the pyramid, and we know the pyramid has face length 10 for one side, and we know coming halfway across in the right angle triangle can be 5, so we can find x by using Pythagoras' rule. And then that will lead us to h. So x will equal the square root of 10 squared minus 5 squared, Pythagoras' rule. So x equals square root 75. So now we know that x is square root 75, we can find h. H will equal, and if you look over here, h is one of the small sides, so it will be the square root of the hypotenuse, which is x squared, square root 75 squared minus 5 squared. And the square root of 75 squared is square root 75, so we've got square root 75 minus 25, so h equals square root 50. So if we go over to our original formula, v will equal 1/3 of our base squared, which is 100, times the square root of 50, the height. So we can use a calculator to finish off, which comes to 235.7, but we've been asked to do it to three significant figures. Make sure you spot that, three significant figures. So the answer is 236 centimetres cubed to three significant figures. Now, in part 2 of the problem, we've been asked to find the size of angle DAB. DAB. So if I draw a diagonal line between B and D, we can see that the angle DAB is in this triangle. Now, it's not a right angled triangle. We can't see that there's any right angles in it at the moment, so we know that our sides are 10 and 10. We don't know the diagonal, but we can find that by using Pythagoras' rule. So if I trace out the right angle triangle, because this is a square base, then the triangle BDC, or BCD, is right angled. So I will draw that here. And what we know about this particular triangle is we know that the hypotenuse is BD, that's what we're trying to find out. We know the two lengths are 10 and 10. So to find length 10 using Pythagoras' rule, as the hypotenuse will equal the square root of 10 squared plus 10 squared. So it's going to equal the square root of 200. So we have our triangle, 10, 10 and square root at 200, and we're trying to find the angle DAB. I'll just put B, A and D in there so that's clear. So we can use the cosine rule to do this. So the cosine rule, you can look it up at the front of the booklet. It will tell us that the square root of 200 squared will equal the other two sides squared and added together minus 2 times 10 times 10 cos x. Remember, when you're using the cosine rule, that the side length and the angle go at the start and the end that you're using as your pair. Now, what's interesting with this is that you're going to see quite quickly, that's why it's only worth 2 marks, this question, is the square root of 200 squared is 200. So 200 equals 10 squared, and 10 squared is 200, minus 2 times, well, minus 200 cos x. Now when you take this 200 to the other side... Hello? Hello? Yes? What do you want?
Yep.
Hello, sweetheart. What are you on your head? Oh, I just had it on me, I took it accidentally. What you got on your head?
Well, a hat's on my head, it's cold outside.
Oh, okay. I hope you've been working hard.
Oh yeah, it looks like it, doesn't it, girls?
Yeah.
Yeah.
You wear that t-shirt to your work?
Daddy!
If I was there, I'd probably put you in.
Yeah.